Let me welcome all of you to the 23rd lecture of the Drilling and Blasting Technology course. In last two classes we are discussing the explosive properties and the different testing procedure of those properties. Still in this class also we will continue those things. So, as every class we do, let us retrospect the previous lectures. In last classes, two classes we are being introduced with the explosive and explosive accessories, and we are trying to understand their need of evolving these different accessories, and we are in a position to understand the important properties related to explosive. And so far we have already discussed about the three important properties, that is the VOD, density and the strength of the explosive, and the different testing procedures for those are also discussed. So, our learning objective remains same, that we are understanding the different physical and chemical properties of the explosive, which are required for the required for the designing the blast, and their testing or measuring procedures, so that we are able to understand or measure the those properties, and accordingly we can modify our design. So, in this class we will try to understand what are the other properties which is having significant impact on the performance of the explosive, but prior to that let us observe this demolition blasting video, which is carried out in a Chinese city, where the complete construction is demolished using the explosive simultaneously, and this is the view you can observe, which is taken from the drone camera from the top, and the blasting is carried out simultaneously. Almost few thousand of houses are demolished here, high rise buildings are demolished with simultaneous blasting, and you can see if it is carried out manually, this may take huge time, but as it is carried out using the blasting technology, the complete structures are demolished within a few seconds, and you can see almost all the structures are demolished except one was unable to blasted because of some other reasons. So, blasting is a good tool which not only can be used for excavation of the rock, but for the demolition also this can be used significantly, as you can see from this video. But for all this we should understand the different properties. So, the other important properties except the density, VOD and strength parameter of the explosive, the important properties are the sensitivity, thermal stability, waterproofness, gallery test and incendiarity test. These last two tests are important for blasting carried out in the explosive medium, but these three properties are important in general purpose of the use of the explosive. If you recall, when we are discussing about the dynamite or the invention of the dynamite by Sir Nobel, we are discussing about the sensitivity. That time we have discussed that sensitivity should be such that the explosive should not be too sensitive. That means there is a chance of premature explosion during the handling of the explosive. Neither the explosive should be too less sensitive, that means we need to have huge amount of shock energy to explode the explosive. So, that is why the sensitivity is very important. Simultaneously, if you see the thermal stability, this thermal stability is important for two purposes. One is that for the storing of the explosive, second one is the use of the explosive in a hot condition, because the climatic conditions may be different from the countries to countries, and it may be different from the use of explosive, position of the use of explosive, that may be different. So, that is why thermal stability of the explosive explosive chemicals are essentially required. Waterproofness is required to understand where the explosives are being used in the watery holes. So, that is also another very important parameters. Not only that, this waterproofness is also important where we are using detonating fuse or similar type of explosive accessories in a rainy atmospheric rainy condition, or the maybe the through which the detonation is being passed, that area is filled with water. So, that is why these are important factors, and that has to be considered during the consideration of the explosive properties. And for that we should see what are the possible test measures are there available with those things. So, sensitivity is basically a measure for explosive dictating its easiness to the impact for detonation. So, that means sensitivity is basically give us the measure that how sensitive is the explosive on a given shock, whether it is being detonated with a small shock or it needs a very high shock for the detonation, or it needs some moderate shock for the detonation. So, for this the test is carried out, for the same is called rifle bullet test, where the shock is given by the bullet which is triggered from a rifle. So, what is carried out in this test? In this test, a 7.62 bore bullet is fired from 22.5 meter distance from a rifle, which gives the bullet a velocity of 826 plus minus 9 meter per second. So, the rifle is fixed, the bore of the bullet is fixed, that means the mass etcetera of the bullet is fixed, and the distance is also fixed. And which type of explosive is used? The explosive is also fixed. The explosive should be of 75 mm diameter cartridge, and the explosive must be fitted with a detonator. The explosive must be fitted with a detonator or whichever is required for detonating that explosive. That means, if the explosive is not detonator sensitive, it is booster sensitive. In that case also we need to provide a booster fitted to the booster is fitted with the detonator. That means, the complete set of initiation system must be provided. Suppose if you see, this is the explosive cartridge which is cap sensitive, that means detonator sensitive explosive. In that case we must provide a detonator inside the explosive, and then we subject the explosive under the rifle bullet test. Okay. So, that the bullet will hit this explosive, and the explosive is on a condition where the shock may detonate the total system. So, we will see the shock provided by the rifle bullet is able to initiate the explosive or not with the full initiation system. That means, if this rifle bullet test is giving a X shock pressure, whether the X shock pressure is able to initiate the system or not. Similarly, if the explosive is non-cap sensitive, in that case the explosive must be fitted with a booster or cap sensitive explosive, which must be fitted with a detonator, and the total system will be subjected to the rifle bullet test. So, this is the principle of this test, and this principle is very good to understand the sensitivity of the total explosive system or the charge system, whether it can be prematurely blast or not. So, we should understand the second property, which is thermal stability. Thermal stability for an explosive is important to understand its storing requirement. So, basically it is carried out for the storing requirement. Generally both the temperature and humidity are changed to observe their impact on the stored explosive. Okay. So, in this case we change the temperature and the humidity and see their impact on the stored explosive on different conditions. The first condition is that 27 degree plus minus 2 degree centigrade temperature and under the normal atmospheric humid condition. The second storing is the 50 degree centigrade, that is the high temperature which is provided thermostatically controlled chamber, and we see the impact of that high temperature on the stored explosive. Third one is that alternately 50 degree centigrade and 25 degree centigrade for 12 hours in each condition, and both the chambers are thermostatically controlled, and we see if there is any changes in the chemical compositions of the explosive or not. So, that means if the temperatures are being varied 12 hours 25 degree centigrade and 12 hours 50 degree centigrade, and the explosive chemical is subjected to this thermostatic changes, and we see if the impact of the temperature is there on the explosive chemical is there or not. So, using this we try to check the thermal stability of the explosive. But there is another, this is of the stored explosive, but there is another point of concern about the thermal stability of the explosive, where the hot hole blasting is being carried out. So, first we should understand what is called hot hole blasting. Hot hole blasting basically a type of blasting where the temperature of the blast hole is very high. Normally we consider any blast hole having a temperature more than 70 degree should be considered as the hot hole. So, hot hole blasting is a point of concern in blasting as the temperature of the hole is significantly high, and as the temperature of the hole is high, if we place our normal explosive inside that hole, that means the hole is charged with the normal explosive, there is a chance that the explosive may be prematurely detonated because of the heat which generates the gas from the chemicals of the explosive, and under confined condition the pressure will build up. If the pressure will reach to the detonating pressure, the explosive will be initiated. So, that may be a premature detonation condition, and everyone which are carrying out hot hole blasting must be careful about this. So, in this case the advised tests are drop and impact sensitivity of the hot surface and the thermal behavior in confined and confined situation of the explosives. So, these two tests are important for analyzing the thermal stability of the explosive. I am not going into the details of this test. Anyone who are interested to have a look on this test, they can see the reference. In the reference the book name is given, is the Explosive and Blasting Technology, written by G.K. Pradhan. The details of these tests are available there. The similar test setups are also available in the internet sources. So, the detailed knowledge can be acquired from this. Because of the time constraint, we are not going into the details of those tests. So, next one is the waterproofness. The mostly waterproofness is carried out for the detonating fuse, and to ensure that in wet condition also, especially in rain, it should continue the detonation. So, there is no chance of cut off the detonation in between because of the presence of the water. However, in the watery holes, explosives of waterproof types is required to avoid the misfire or poor explosive performance. And in this context, I must remind you that we consider this similar one while we are discussing about the density. Any explosive which does not have the density more than 1 cannot be used in the watery holes, and any one which is of some hygroscopic nature should not be used in the watery holes. So, similarly, what we do, we do not use ammonium nitrate fuel oil as an explosive to the watery holes, because ammonium nitrate is hygroscopic, it dissolves in water, and what will happen, the explosiveness of the ammonium nitrate will be lost if we place the ammonium nitrate in the watery holes. However, in some cases ammonium nitrate based emulsion or slurry explosive may be used, because those are, in those cases ammonium nitrate that prilled contents are be surrounded by the oil fields, and that is why they behave like a waterproof explosive. So, waterproofness of the explosive inside the hole is required when the holes are watery, may be due to the rainwater or may be due to the underground water, groundwater. In those cases waterproof explosives are required, otherwise waterproofness of the detonating fuse is very important for understanding the continuation of the detonation pressure from one point to the another point. Next, we should understand something about the next two tests which are essentially required for the explosive environment. So, in this context, let us have some knowledge about the explosive. Special explosives are required to carrying out blasting in the explosive environment. So, what will happen when we carry out blasting in the coal mining sector etc., there are some typical problems arises. What will happen? Most of the coal seams by nature contains methane or other hydrocarbonaceous gases entrapped into the seam itself. With the mining of the coal, these entrapped gases are released, and by mixing with the oxygen of the atmospheric oxygen in the air, it forms an explosive environment. So, particular percentage of methane, particular percentage of oxygens are mixed, they create an explosive environment, and if a naked flame or some heat is injected into that environment, it will blast. So, this type of blasting is called fire dump explosion or methane air explosion. That is why for practicing blasting may trigger the methane air mixture and convert that into the fire dump explosion. So, while blasting is carried out in the underground coal mines or blasting is carried out in a place where there is a chance of entrapped methane, occurrence of entrapped methane is there, that time all should be cautious enough, because that basically depicts the explosive environment. So, blasting carried out in the explosive environment is very dangerous, and precaution must be taken for that. What is the first precaution? The first precaution is that to avoid that situation, we have to control two things. First is that one is we have to drain the methane ahead of the blasting. We have to drain the methane ahead of the blasting. The second one is the controlling the heat so that heat and flame cannot be generated from the blasting to arises such a situation that it will explode. So, first one is very difficult and may be time taking. So, to carry out the blasting, the second option is mostly carried out, and to address the second option, a special type of explosive was developed, which is called permitted explosive. What is this permitted explosive? These permitted explosives are the explosives which are allowed to use in the underground coal mines, that is in the explosive environment. But the problem is how we will define these things as the permitted explosive. So, let us see what is there in the permitted explosive. So, permitted explosive is basically nothing but an explosive contains some quantity of quenching or sheathing material to arrest or reduce the flame or heat of the flame. So, there are some sheathing or quenching material which basically quench the flame or basically sheath the temperature of the flame, or there will be no case that flame will be arises, and that is why heat or flame will not be there. If it is there at all, it is not of that much magnitude that will ignite the methane air mixture. So, basically what we are doing, we are mixing some quenching or sheathing material with the normal explosive types, so that we can make it the permitted explosive. And based on this, based on this there are 3 classifications, there are basically 5 classifications of explosive, permitted explosives. First let us discuss permitted 1, 3 and 5, we will discuss 2 and 4 later on. The permitted one, which possess limited salts, basically salts are the common material which is used as a quenching or seething material and can be used for degree 1 gassy mines. That means, degree 1 gassiness, let us discuss something about the gassiness here. Degree 1 gassy mines basically where the release of methane or hydrocarbonous gases is less than 1 meter cube per ton of excavation of the coal is considered as the degree 1 gassy mine. If the release of that gas is between 1 to 10, it is called degree 2. If it is more than 10, it is called degree 3 mines. That means, degree 1 gassy mines is having the less release of methane, that is why the potentiality of that to become a showing an explosive environment is less. So, we need less quenching material, and that is why the permitted 1 explosive is there, where the limited salts are used, so that the quenching can be or quenching or seething of the flame can be available on that case. Second one is the degree 3, second one is the permitted 3, which can be used for the degree 2, degree 3 gassy mines, where the release of methane is more, that is why the possibilities of having an explosive environment is high, and in that case there will be extra precautions should be taken, so that so that the flame or heat cannot be arises there. That is why extra quenching or seething material, extra quenching and seething material should be used. But for these two cases, we have used the first technique. The first technique means the release of methane from the atmosphere is carried out beforehand. So, these first two cases, the release of methane is carried out somewhat by providing a small cut in the face ahead. So, suppose this is the face where blasting has to be carried out. In that case, what we do? We provide a cut beforehand, so that the methane can be released from this cut and go to the atmosphere beforehand, when we take out this methane from this place to the outer place. So, the methane content in the coal will become less for these two conditions, and that is why the salt requirement of these conditions are less, because we are taking out most of the methane beforehand. So, that is why this permitted 1 and permitted 3 explosives are used for the cases where blasting is carried out after a cut is made, in the face and allowed the drainage of the existing methane in the face. In those cases, this permitted 1 and permitted 3 explosives are used. Permitted 5 explosive is used where there is no cut. That means, full phase blasting is being carried out, by drilling and placing the explosive, and there is no drainage of methane beforehand, is there beforehand. So, that is why basically the blasting is carried out with the full methane content in the coal, blasting is carried out, and that is why the expectation is that the maximum quantity of methane is available in this, and that is why this type of blasting is called solid blasting, and this P5 explosive must possess the most quantity of salts, and that is why it can be used in the solid blasting. So, permitted explosive 1, 3 and 5 is now well known to you. Permitted 1 is for the degree 1 cut blasting, permitted 3 is for degree 2, degree 3 cut blasting, permitted 5 is for cut blasting for all degree 1, degree 2, degree 3 mines. But you may ask where is the permitted 2 and permitted 4 explosive. The permitted 2 or permitted 4 explosives are basically developed for avoiding the patent problem. Permitted 2 is basically equivalent to permitted 1 explosive. So, it is developed to avoid the patent. Permitted 4 is equivalent to the permitted 3 explosive. It is it is developed to avoid the patent for the degree 3 permitted explosives, permitted 3 explosives. So, that is why this permitted 2 and permitted 4 are not commonly available in India. Permitted 1, permitted 3 are replacing this permitted 2 and permitted 4, and this permitted 1, 3 and 5 are sufficient for any place to use these things. But the problem is that how this permitted explosive can be certified that these explosives are of desired quality or having the desired quantity of quenching material, and those quenching materials are performing well. So, for this it is required to have explosion proof tests, and this explosion proof test are described as the gallery test and incentivity test. So, gallery test is carried out to check the explosion proof of the permitted explosive. In this in this case, explosive environment is created either by methane air or by coal dust air mixture in a very thick steel chamber. Explosive environment is created by methane air, so that we can talk about the fire dam explosion, or coal dust air mixture, which can be considered as the coal dust explosion, and that explosive environments are created in a thick steel chamber. Then we initiate the explosive which is subjected to that explosive environment and see whether the quenching material is sufficiently able to quench the heat of the flame of the explosive, so that no explosion to the environment occurred. That means, no explosion, no fire dam explosion, no coal dust explosion is occurred. So, this is basically the gallery test carried out to give the certification to the permitted 1, permitted 2, permitted 3 and permitted 5 explosive. Similarly, incentivity test is carried out for the detonators, where the detonators are allowed to blast in a closed explosive environment. So, what carried out here, the explosive environment is created in a chamber. So, in this chamber explosive environment is created. Similarly, like coal dust or methane air mixture, then the detonators are provided, very often not a single detonator. Often we can change from a single detonator to a number of detonators. That is either in series connection or in parallel connection, series or parallel connection. A number of detonators are fitted in this chamber and that is allowed to be detonated, and if it ignites the explosive environment, then the huge blast will occur. This magnitude of this blast will become very huge, and if huge blast occur, then we consider the detonator is failed in the incentivity test. That means, the detonator is not sufficient to be used for the underground explosive environment. Generally what is happened in detonator, the base charge is PETN and this electrical flux is given a flame to the primary charge, which is nothing but the azides and stiffnets. So, this base charge which is initiated may ignite the explosive environment, that the methane air mixture or something like that, and here to reduce the heat of that, a conductive material or case is used as the outer part of the detonator. Normally what is used here, it is the copper tubes are used. These copper tubes are used as the conductive material, so that the heat generated by the initiation of the PETN or the initiation of the ASA, the heat generated from there are taken by the copper casing, and that is why the heat coming to the flame has to be reduced enough. But as the copper is very costly, often there is a tendency of the manufacturer that they use aluminum or iron tubes, and it has been found in a number of tests that these tubes failed to pass this incendiarity test, and that is why in most of the cases the copper tube detonators are only allowed those which are passed in the incendiarity test. So, that is why especially those thickness of the copper casing etc., and their purity, so that the thermal conductivity can be accepted, it can be observed as the accepted level. So, those are very important in this case. So, incendiarity test is required to identify whether the detonators can be allowed to use in the explosive environment or not. So, there are n number of other tests are also there, which is essentially required for the understanding of the explosive and their accessories, as the acceptance and their acceptability in the different condition. But because of the time constraint, it may not be possible to address all those tests, all those properties to be discussed in this lecture. I request you please go through the different manufacturer website, where those test specification of these tests are given. You will get a good description of this specification of those tests and properties in this book also, is the manufacturer website. Apart from that, some of these tests are available with the CIMFR, with the manufacturers, labs of the manufacturers, especially Nitro Nobel etc., those reputed manufacturers, Orica, you can find out these test facilities are available. So, you must go through those facilities, you must go through those properties, importance of those properties by yourself. So, this is all from this lecture. In next lecture we will discuss about the explosive thermochemistry of the explosive and the explosive rock interaction. Thank you.